Picking up from part 1, we're going to add wind to our trees, cover 2 different ways to add grass, dynamically generate a field, and add a river that cuts through the landscape. Let's jump back to our forest at the end of part 1. I highly recommend starting with part 1 if you haven't watched it. Our forest looks pretty good, but the trees aren't moving. It feels very lifeless. Let's add some wind. To do that, we will swap out the tree's static meshes for skeletal meshes. Open up the procedural vegetation graph from the trees we made in part 1, and add a new output node for each tree type. I'm going to update the new output names to use an SKM prefix for skeletal mesh, instead of SM for static mesh. Then set the export mesh type to skeletal mesh. Make sure create nanite foliage is set to true, and use the default tree wind settings. Then let's click the export button in the top left and batch generate our skeletal meshes. This is going to take a while, so let's skip forward. Now that we're done, open up the PCG graph. To use the skeletal meshes, let's add a graph parameter. I'm going to name it skeletal trees. Then change its type to a skeletal object reference and change it to an array. Then add the skeletal meshes we just made to the array. We are going to replace the static mesh spawner. Add a get graph parameter node. Its property path is the name of the parameter we want, so let's set it to skeletal trees. Drag off the density filter and add a match and set attributes node. We are essentially appending our skeletal trees parameter to the results of the density filter. I forgot to do this, but on the getGraph parameter node, we have to give the skeletal trees a new name for their output from the node. So let's name them skeletal trees output. Drag off the match and set attributes node and create an instanced skinned mesh spawner node. For its mesh selector mesh attribute, we want to select which attribute contains the meshes to spawn. So we set it to skeletal trees output. There are lots of options in here. The one we care about for enabling wind is transform provider. We'll set it to the default wind transform provider object. We can now delete the static mesh spawner completely. If we go back to our landscape, voila, our trees are swaying from wind. I don't like these wind values, so let's customize it with the BP Global Foliage Actor UE5. Drag it into your level, and the wind in the level should automatically start matching what you set in the actor's wind variable. If it isn't, you may have dragged in the wrong global foliage actor. In my project there are 2, one that works and one doesn't. You can also rotate the actor to control the wind's direction. Next, let's add some grass to our landscape. I'm going to show 2 ways to add grass. The first is by adding a landscape texture grass object to your landscape's material. Open up your landscape material. Ours is named mLandscape from previous tutorials. Right-click and add a landscape grass output node. Then right-click and search for landscape layer sample. We'll specify which layer we want to sample by entering its name into the parameter name. We have a layer called grass, so let's name it grass. It can be any layer's name. Connect that node into the landscape grass output. So with these nodes, we are saying anywhere there is a grass layer painted on our landscape, we're going to spawn a landscape grass type object. Open the context menu and search for landscape grass type. I'm going to name it LGT for landscape grass type _ grass example. Open it up, and you will notice it's not super complicated. The grass varieties array is an array of grass meshes we want to render, so press the plus button to add an entry, and we will set its mesh to a cone for now. There are other settings like density, but for now, leave it as is. Back in our material graph, set the landscape type to our new LGT grass example. Now we just open the landscape mode in the editor, select the layer grass, and if we paint the grass layer, cones will also be rendered on the ground. Pretty neat. Let's upgrade from cones and jump into Fab to download some grass meshes. I always search for free products, and I'll be using this wild grass from Quixel Megascans. Let's press export, and now it is added to our open project. I find the mesh names hard to work with, so let's rename them to wild grass A, B, C, etc. Then let's open each mesh and select Enable Nanite Support and apply changes. Then if we go back to LGT grass example, we can swap out the cones for wild grass meshes. You can add more entries into the array and they will be spawned as well. The LGT grass object has some built-in optimization settings. Meshes are only spawned if they are within your vicinity. The start and end culling distance settings control how far away and how quickly meshes fade. To show this behavior, let's use really short distances and set the start cull distance to 500 and end cull distance to 800. Now as you move, you can see the grass spawning in. In practice, you'll probably want the grass culling to be more gradual and over a longer distance. The other way we can add grass is by procedural generation, similar to how we did with trees. Let's start by clearing out a space in the trees for a field. To do that, select the PCG graph and add a spline component to it. Then let's draw our spline and set it to closed. Let's move our spline further away from the mountain and lower it a bit. Back in our PCG graph, we can get a reference to our spline. Right-click and add a Get Spline Data node. We will leave the actor filter to self because the spline is a component of our PCG volume. Drag off the Get Data spline and add a spline sampler node. Debug the spline sampler node, then set dimension to on interior, and you will see that the space inside the spline is filled with points. Now let's project our points onto the landscape. Add a projection node and add a Get Landscape Data node for our projection target. Nice, now the points are on the ground. Let's take our spline points and use them in a difference node with the tree points. This will cause tree points that overlap with our spline points to be removed. And just like that, the trees are not spawning inside our spline. It looks pretty good, but maybe we want to blur the tree line between forest and field a bit. On Spline Sampler, there is an interior density fall-off curve. This lets us set each point's density value based on how far they are from the center of the spline's area. A higher value along the x-axis means it's closer to the spline's edge. So set the first value to 0, 1, i.e. a density of 1 or white when we're near the center of the spline, and set the second value to 1, 0, so density is 0 or black when close to the spline's edge. If we debug the sampler, we can see this gradient. Feel free to set this gradient to whatever you want. Anyway, we want a lot of noise in the gradient, so let's add an attribute noise node. Set its mode to add, input source to $density, and output target to @source. Let's set noise min max to -0.2 and 0.2. Now we see some trees sneaking into the spline's limits. You can play with the gradient and noise values to something you like. I eventually settled on -0.5 and 0.2. Now we want some grass inside the spline's limits. So let's add another spline sampler, set its dimensions to on interior, and debug it. Let's increase the interior sample spacing to something like 200. Then add a transform points node so we can break up the grid pattern. We'll add an offset min and max along the x and y axis to -200 and 200. Then let's project our points onto the landscape and add a static mesh spawner. We will set its mesh entities to the wild grass, A, B, C, etc. that we created earlier. If we fly down, the grass is there, but it's very small and sparse. We can go into the transform points node and increase the scaling max to something like 5 and a min of 2. It still looks kind of sparse, but let's wait on adding more grass until we've added other things to our field. Before we move on, let's enable wind for our grass. Go to one of the static meshes for wild grass and inspect its material instance. This material instance happens to already have a setting for enabling wind. Let's turn it on, and the grass is waving. Let's add some more diversity to the field and jump into Fab and grab some rocks for our landscape. I grabbed Mossy Forest Boulder, Military Trenches, Scattered Rock, and Rock from Quixel Mega Scans. They were free when I got them, but it seems like less and less things are free than they used to be. If they aren't free, you don't have to use these exact assets. Any mesh will work. Clicking Export on each one will add them to our project. I'm going to confirm each rock looks okay, enable Nanite on them, and rename them to something more useful, like Field Rock A, B, and C. In our PCG graph, our rock nodes are going to look similar to the grass nodes. Create a spline sampler. Let's make the interior spline sampling spacing much bigger, like 900. And add a transform node to break up the grid layout and sizes. Then, let's project the points onto the landscape and add an attribute noise node to make their densities random, and then add a density filter. I only want a couple rocks, so I'm going to filter out 90% of them. Then add the static meshes of our rocks in the static mesh spawner. Next, I'm going to add some flowers to our landscape, but you can pick out what you want on Fab. A list of the flowers and plants are listed in the description below. It's the same pattern as how we did the rock. So let's skip forward. Okay, I added the plants and it's looking nice. Now is a good time to go back and bump up the grass density to something that feels reasonable. Let's walk around in game and it's starting to feel more like an actual place. One note is that we are testing in standalone mode and not in the editor. Playing in the editor has some overhead that makes things more choppy. Last thing for this tutorial, let's add a river that cuts through the forest. Go to plugins and add the water plugin. It's going to require restarting to enable. Let's hit the plus button, search for water, and drag in a river. Just like that, we have a river, but our trees are overlapping. To remove the overlapping trees, let's go back to our PCG graph. Add a Get Actor Data node, set filter to all world actors, and set actor selection to by class, and set the actor selection class to water body river. Pass that into spline sampler node. Then we will change the mode to distance. If we debug our spline and look at it, we see points along the spline. So now we just have to transform those points to match the width of the river. Back in the PCG graph, add a transform points node. Turn off uniform scale, and let's start bumping up the scales to fit the river. Increasing along the x-axis isn't very noticeable because it follows the spline's path. Increasing y will make the points wider. 9 seems pretty reasonable. And then we want to increase z by a lot because we want it to reach the bottom of the riverbed. We can bump it up to 500 no problem. Then we just add a difference node, like in the previous examples, with the tree points being the source and the river spline point being the difference. Now we can draw our river through the landscape and trees around it will be removed. This part is just adding and adjusting spline points. It's nice to see our automatic system starting to build on top of each other. You can see the automatic landscape material adding dirt and stone to new slopes created by the river. At this point, you can start mixing procedural generation with hand-placed design. For example, say we want to place another field somewhere. We can now just duplicate our spline from the field and drag the new spline anywhere else on the map. I think that's it for this tutorial. Subscribe to the channel for more videos. Thanks. Bye.